Start now. We can start the last GRSS webinar of the year. This webinar is organized by the GRS Standards for Earth Observation Technical Committee. The title of this webinar is Earth Observation in the NewSpace Era, Insights on IEEC Missions. This webinar will be given by Estefania Blanch and Helena Carré. Estefania is an Earth Observation Project Manager at the Institute of Space Studies of Catalonia. She holds a PhD in geophysics from the Everett Observatory and previously worked as a member of the Aeronautical Research Group, specializing in ionospheric physics and space weather. Helena Carré is the head of the infrastructure office at the IEEC, where she leads initiative aligned with the Catalan NewSpace strategy. So thank you for this webinar, and please go ahead.
Thanks a lot, Hugo. So good morning or afternoon, everyone. My name is Helena Carré, and today with my colleague Estefania Blanch, we'll share some insights on how NewSpace Earth observation missions, such as the ones that we develop at the IEEC, are driving innovation and can contribute to Earth observation data science. So to start, let me introduce you briefly to the IEEC. It was established in 1996, and we promote the space-related activities in Catalonia with a focus on astrophysics, Earth observation and navigation, and space technology. The IEEC counts with a total of 275 members dedicated to advancing knowledge and innovation. Next, let's take a quick look at the NewSpace strategy of Catalonia, which sets the foundation for the projects we'll discuss today. This strategy was promoted by the Government of Catalonia in 2020 to boost the space ecosystem in the region, and it's organized in 6 main pillars: fostering innovation, collaboration, and sustainable growth. The projects we'll cover in this presentation are inside the pillars of infrastructure and data and adoption of new space services. So the model we approach with Earth observation missions is what we call mission as a service. This model redefines how satellites are planned and used. The IEEC designs and contracts mission services, securing Earth observation data of the region. At the same time, the contractor retains the ability to commercialize the remaining satellite capacity. This approach has several benefits, from which we highlight the cost efficiency as the investment is shared. And since we're involved in every stage of the mission, we can design platforms that support in-orbit demonstration programs for hosted payloads. The first Earth observation mission under this approach was Genius 01, also known as Menut, which means small in Catalan. Menut was launched in January 2023 and is based on a 6-unit CubeSat platform. It operates in a low Earth sun-synchronous orbit and carries a multispectral camera with 7 bands spanning between 400 and 1000 nanometers. Menut also includes an IOD payload, which was developed by the IEEC and is a demonstration of a high-performance onboard computer. The satellite was developed in partnership with Open Cosmos Europe and with the technical support from the Cartographical and Geological Institute of Catalonia. Building on Menut's success, we are now working on the second mission, which is Genius 02, which is set to be launched mid-2026. In this mission, we are targeting high recurrency rates in data acquisition, which will be achieved by complementing this satellite with at least 2 additional satellites in similar orbits. This mission will feature a larger microsatellite platform, around 50 kilograms, with 2 optical payloads in the Vineyard and Suir regions. A secondary payload will also be hosted for IoT communication, and finally we'll also have a hosted payload for IoT purposes, which is the in-orbit LISA diagnostic demonstrator. This mission will represent a significant step forward in capability and versatility of our observation program. And next slides will be covered by Estefania.
Okay, thank you very much, Helena, and good morning, good afternoon to everybody. I will continue with the presentation. This is maybe the second part of the presentation on what we are using this data. And here we don't want to talk about these different data processing levels. What we want to do here is to talk about the standards that we use to process this data. we want to highlight that we want these missions to be complementary with Sentinel-2, for instance, and also complementary with other satellites that can be used and can be used in the same time. And also we can use the fusion of data of different satellites. And the standards to obtain this data for this mission is important. Here, we wanted to highlight that we will have this metadata. This data will be time referenced and also accompanied for auxiliary information. We use the reference system, the WGS84 and the projection UTM31 North, because what we are talking is about is over Catalonia, this is why we use this reference and projection. And also that we will use the different geometric and atmospheric corrections. And finally, the data will be provided and using in GeoTIFF format. And this data will be accessible using a free access to everybody. And this data will be only for the Catalan territory, because it's the data that we are, or the ownership of this data. Then it's important the use of these standards at different processing levels. What ensures is that the Earth observation data can be useful, operable, and comparable. This is what we want in these missions. Helena has already explained you about the new space strategy in Catalonia. And one of the pillars is the adoption of the new services. Within this, the new strategy, we have developed different mechanisms and different programs that want to promote the use of satellite data. We have what you can see here. I don't know if you can see my mouse. 1 second. What we have different programs, the Open Innovation Services for private sector and also for public entities. And we want to share with you some examples that we have been done in this Open Innovation Services procurement that we coordinate at the Institute of Space Studies of Catalonia. This Open Innovation is an Earth observation use case ideas competition for the private sector. And we have launched this program. Is a program that has for the last year. It had two winners for these competitions. Each winner had a financial support of 50,000 euros. And the use cases had to be, as you can see here, the requirements had to be innovative. They had to be based on Earth observation satellite data, including data from MENUT as a demonstrator of its capabilities. This was a key requirement because we wanted to test and show the capabilities of this mission. These use cases have to be targeted to the private sector because we want to promote the use of this Earth observation data among the private sector, among the ecosystem in Catalonia. These use cases have to be applicable to the Catalan territory as a proof of concept, and thinking always that this proof of concept in Catalonia can be developed in other countries. And which was very important for us is to include the active participation from the end user, because we wanted to solve existing and real problems that the end users, and in this case, the private users have. And just to finish this, the requirement is that it was a 6-month development of each use case. You can see here in the bottom, these are the two companies that were awarded with this program. One is the ISARSAT company, which developed a project for the high resolution drone monitoring. And the other company was SpaceCat, that has developed an application to manage the different agriculture, the agriculture in the region of Catalonia for wine nuts. And what we wanted to show you here is the results of these use cases and how the data from these satellites, from these missions, from MENUT, performs when in these cases. You will see that we have shared different data from different satellites. Each use case use different data sets, and you will see how MENUT behave in these examples. This is the first use case that we want to show you is the MARE, which is like mother, but is the acronym for High Resolution Drought Monitoring in Catalan. This is developed by ISARSAT and together with the two end users that were the irrigation, they have to manage the irrigation plants in different areas of Catalonia. As a context of this use case is that ISARSAT, they have already implemented and validated an operator processor that generates surface and subsurface soil moisture at a spatial resolution of 1 kilometer. They have developed this processor using data from SMOS and SMAP in combination of thermal and optical data from Sentinel-3 and MODIS. They have different maps. You can see here, this is an example for the Ebro Basin. And they have these maps since 2010. And they have a spatial coverage, global spatial coverage, these satellites. Then this example here can be done in another place. And the temporal resolution is 1-2 days, but the spatial resolution is 1 kilometer. If we want to use this data or these maps or this information in a territory as small as can be Catalonia, is small and it has the geography. It's different. It has a lot of differences of geography in this region. We need a better resolution for these maps. Also, this company ISARSAT with this processor, they have been monitoring the weekly water status of the vineyards in Terra Alta, also in Catalonia, since 2020. They are collaborating with other institutes, the Observatorio del Ebre and the Government of Catalonia, and they provide these maps of soil moisture for 1 kilometer for this region. This is a small region in Catalonia, and then 1 kilometer of resolution for soil moisture is not enough for this region. And now what they have developed in these use cases that we have financed is to improve this resolution using different methodologies and also using MENUT as a demonstrator. This is the objective of MENUT, the objective of MENUT and this project with MARE. The main objective is to improve the drought monitoring capabilities in Catalonia, and the pilot has been done in different areas of Catalonia. And the main objective is to improve the irrigation needs and also to improve the forecast yield. And how they have done this use case, they have been using data from Landsat 7, 8, and 9 that has 100-meter resolutions. Then we improve this resolution and combining with the SMAP, which has this 9-kilometer resolution. Then with this combination, they already get a spatial resolution of 100 meters. And which was very important here is that using these 3 Landsats, the 7, 8, and 9, it allows to have a frequency of a weekly average frequency to have these maps every week, because the bulletins that they already provide to the end users, they are bulletins at every week. Then they needed this temporal resolution of the satellites to be able to have weekly average maps of information. This is why they use these different Landsats. And they have data availability since 2015, since nowadays. What And then this long-term data, what has allowed is soil moisture and to calculate the soil moisture anomalies. And then you will see that they have developed a drought index in these areas also. And then just to finalize this, the objective of this project is that they have been using Menut as a demonstration, and they could get data of the soil moisture at a spatial resolution of 5 meters. This is an example of the results they had at the beginning. This is a region again in the Terra Alta in the west of Catalonia. They had these maps of soil moisture at 1 kilometer resolution, and now at right you can see the 100 resolution of the solar moisture maps in the same region. And as I already mentioned, that what they have calculated is the mensual mean of this data since 2015, and it has been able to calculate the drought index, obtaining the soil moisture anomaly relative to this mensual mean. And now what they provide is an open website. You can find the soil moisture at 100 meters and the drought index at 100 meters for these areas that they have performed this project. And the data from Menut has been used. All the algorithm has been modified to ingest the data from Menut. You can see here an image, original red, green, and blue image from Menut obtained in 2023, in July. This is the area of the Ebro River Delta, which at that time, all this green is the rice fields that you can see in the images. And they have modified this algorithm, and what they have done is not using Landsat anymore here, and they use Menut and Sentinel-3. From Menut, they obtain the information from the optical, and they have this 5 meter resolution, and from Sentinel-3, they have the optical and thermal information at 1 kilometer resolution. Using data mining sharpening, we obtain this optical and thermal information at 5 meters with a temporal resolution of 5 days. And this has been fusion with the SMAP. And finally, what we obtained here is the soil moisture for a resolution with a resolution of 5 meters and a temporal resolution of 5 days. And just here an example of what we have. You can see at the left, this is the land soil temperature at 1 kilometer obtained from Sentinel-3. And at the right, you can see a synthetic temperature, a synthetic land surface temperature using this fusion of Menut and Sentinel-3 with a resolution of 5 meters. It's important here to highlight that this temperature of obtained from Menut and Sentinel is a synthetic temperature. You can see that there is no numbers in the legend. We only set here low temperature and high temperature. And what is important here is the difference of temperature to merge with the soil moisture information. And what we have here is already the soil moisture derived from Menut data. We have here now, it is at 5 meter resolutions, and this is the data obtained from Menut, Sentinel-3, and SMAP. You can see, you remember, this is the Ebro River Delta with all the fields with water, because it was it was when the rice was rising, then there is water in all these fields. And we can see that the soil moisture is elevated here in these areas. And this is a town, and you can see now the difference in the soil moisture, where there is a town, there is a street, and also here there is another town. And all this part here in the image is the rice fields. And we can see the difference. We can see that the resolution now we can differentiate between different fields now. It is more easier to differentiate this. This is a comparison of what we obtained using the Landsats that we explained at the beginning. This is the MARE project. What we obtained here, this is the soil moisture for the same area, for the Ebro River Delta. And this is the comparison with what we obtained using Menut. Here in this image, you can see the comparison, the higher resolution using Menut and how Menut behave in this use case. We could use the fusion of data from different satellites, and Menut give us a good result. We have a better resolution. We could merge all this data. And just to compare, we wanted to show what happened if we use Sentinel-2 instead of Menut, Sentinel-2 and Sentinel-3 to obtain the soil moisture data in this area. And we can see here that even this now Menut has a higher resolution, and we can see the difference between the plots much better. And the second use case is a comprehensive application for agricultural professionals of woody crops, based also on satellite spectral information. Here, this use case has been performed using Sentinel-2, and also Menut as a demonstrator, as we ask in the requirements of this project. This project was developed jointly with another private company, which is named AgroPixel. AgroPixel manage different fields in Catalonia of woody crops, basically. Or basically, we could say that vineyards in Catalonia and also in Spain and even in Europe or abroad. And they use an application that they already have. And this application gives information about the different fields, about the owner, about what is in each field, temperature, humidity, and all this information. But in this application that they already have, which is called Pixel Suite, they don't have information about the Earth observation data. They had to use another computer or to do it by hand, and they had to download this Earth observation data from another place and analyze this data. And what this use case has done is that Spascat has developed a module in this Pixel Suite application in which AgroPixel can get the Earth observation images from Sentinel-2 for all the fields that they manage. Then what we have here, this is an example of one of the biggest vineyards in Europe, which is Raimat. And we could test this use case in different fields that they have. They are colored in purple. These are the fields that we have used as a pilot here. And what we have now is that this application, now you can have all this information from all the fields and all the plots. You have the information of the owner, as you can see here. This was already existing, but now just doing some clicks, you have also the information for different indexes, vegetation indexes. Here I show you the information of this plot using the NDVI indices, but here you cannot see it, but the application allows different indexes, or even you can ask, well, here AgroPixel ask Spascat to develop different indexes and to put it here in this application. Now you can see here, this is for this plot, we have information for the NDVI indexes. And then what they have done is that you can select different parts of the plot to know how the vegetation is growing and to obtain the different parts of this plot. And these points here, they indicate that this is a good place to go to do an inspection of this area. Then what before using this application, they had to use like 3 days to investigate which is the best place to go to do an inspection. Now it is done in less than 10 minutes, probably. Then this use case helps this private company to do more efficiently their job. You can see here in this application, you can see that here, this is May 2023. This is the data from Sentinel-2 that is available for that month. And they have also added here the information about the weather to know if that day had enough information, or it was cloudy, it was sunny, to know if the image of the satellite will be enough, or that image will not be useful for what they want. And also in this use case, what we have done is to compare the use of minute data and to know how it behaves, the data of this satellite. And here you can see there is a comparison of different, well, this is the same plot, but this is using Sentinel, and this is the NDVI index using minute. In this case, you can see that the variability, or it's similar in both plots, because here what only changed, we can say that it's the spatial resolution. And then from this information, what we get is that this mission can be complementary with Sentinel-2. That this is one of main goals for us, to be complementary with these satellites, mostly to improve this temporal resolution of the satellites. This is another example using minute. We have another plot. We have here, this is the CCCI index using Sentinel. We cannot see any pattern in this plot. We cannot decide where to go to do an inspection, because we don't see any pattern, because this plot is quite small, and the resolution in using this vegetation index is 20 meters, because this index is developed using the red edge band, and then now we have here 20 meters. And this is the same index, the same vegetation index, using minute, which has a resolution of 5 meters for the red edge band. And now here, what we provide, or what we have, is more information about how the crops are developing. And now here we could say which area we can go to make an inspection or not. And this has been also a nice result, because we can say that minute helps to use different index using these red edge bands. This is just to show the validation, because all these projects has been validated using different data instead of Earth observation, both projects, but we don't have enough time also to show all these validations. But we wanted to show at least one of these. This is a comparison using, this is an image using Sentinel-2, using this application. And this image in the right is the vegetation index, also the NDVI, using an airplane that they have. They own a small airplane, and they have the different cameras, and then they have this information about with these cameras, and they compare the result of both instruments, from the camera of the airplane and the satellite, and they see that the results are very similar. It was very interesting, this plot here. This is why we explained this one, is that in that winter it has they were very cold days, and all this blue area, it was an area that they lose the production of here in the vineyards. And it was interesting how the vegetation index here in blue, it is the largest number of the vegetation index. It means that the vegetation was very healthy. This is because they lost all the production, and then the different trees they grow more than the rest of the trees in this plot. And also a part of these use cases that we have developed, also to explain that using this mission we have also some additional benefits, because we can manage and we can task these satellites as we need in case of, for instance, emergencies. This image here at the left, we have again an image from the Ebro River Delta when it was a cold drop that caused floods in this area. And this help us to see is this very thin area here, if it was broken or not. And we could see that it wasn't broken this time. And this was an example that we used these satellites. And also here on the right, you have an image from a wildfire damage evaluation. And we could, using this the data from Menut, we could delimitate this total burn area in this small area. And just to finish, a brief conclusion of all these use cases, what we have obtained, the benefits of these missions, and the lessons learned also to develop when developing these missions and working with the data of these missions, is that what we have obtained is the data from Menut is useful to complement existing data. This was very interesting to see that Menut can complement the data from Sentinel when we have, for instance, a storm and no data from optical satellites can be used from one satellite. Maybe we can use another one, and we have this complementarity, and then the temporal resolution increase in that area. Then what is also important is to highlight the continuity of the sensors and capture the system levels. It is important, this continuity of the sensor. This is what the Copernicus program here in Europe is doing. This is the importance of the Landsats, also satellites. And this continuity at sensor are very important for this long-term series reanalysis. And this is something that we have to think about for this kind of missions that we are performing to provide these long-term series, because we are now starting, and it is important to provide this data. Also, the data fusion is important with other ground or Earth observation data to validate. This is what we said. These use cases had to be validated, and the data fusion allows this validation. Also, this data has to follow these quality control protocols. Also, this is very important to know how this image can be used, and if they produce all the requirements that we ask. And this co-design that it's important to previously talk with the end user to know what they need, and then we can build these emissions according to their existing needs of the end users. And well, this is what we wanted to explain you this afternoon. This is our experience with these missions, and thank you very much for your attention. If you have any questions, or you can contact us via email.
Thank you so much, Estefania and Helena. This was a very nice presentation and marvelous, work. So congratulations for both the work and the presentation. I think that it covers most of the hot topics in the standards community and the Earth officer community, and you are, working together with academy, industry, government, so it's really nice. I think that today we learned a lot about, the new space, strategy in Catalonia, and it's really nice to see this, this link with the private sector, including, companies, and also the applications for, disaster management, early warning. So it's really nice. I think that you have done a lot of work within the last year. So now it's time for questions. Please don't be shy. Go ahead. We have time for questions. So who is the first one? Okay, I have one question. I think that probably maybe one of the most important aspect and challenge at the same time is the connection with the farmers and the real implementation of application of the data. I think that this presentation covers a lot of aspects related with the IEEC and the relationship with the private industry, but do you have some feedback from the farmers and the final end users? What is your thoughts about that?
Yeah, in the case of these two use cases, the use cases were developed with the end users. They were engaged to develop
Nice.
also the use case, because this was very, very important for us, because sometimes there are the providers, the satellite providers, they develop a solution, but maybe this is not the best solution. And now what we wanted it was to tailor that solution for the end users. And they were really very proud of that, and they chose what they wanted for the use cases. And now in the case of the Viñeras, there is AgroPixel, they already have these applications that they have developed, or they asked how to develop, and they are using it. And well, it has been a nice experience to do it like this. But also we have to say that we did a small conference with other end users and other agricultors, and they said that it's sometimes it's difficult to use by themselves these kind of applications, because sometimes they don't understand how to use the application, or how to interpret the images, or if they interpret it well or not, and which kind of information these images give them. And they said they need some support from technical part also.
I think that maybe the requirements, for example, in terms of soil moisture, are very different from the scientific community to the farmers. I mean, maybe a farmer just need to know if the soil moisture is low, medium, or high, and forget about the numbers. Just having a rough idea of how much water they need to use for the agriculture. So that's very interesting. And regarding future trends and long-term plans, could you give some ideas or some thoughts, or still you are working on?
We already started working on our second mission. We focus on one side on data continuity, but also since we've seen this trend of the new space or new space companies develop capacities for larger platforms, we will also benefit from that with extra payloads for Earth observation, or for example for communications, as we chose to explore data mixture with IoT.
Very, very nice. I think that maybe we can open the floor for the attendees. So any question or comment, please?
There are some questions in the chat.
Okay, so you can open the chat and check, please.
Wait a second. This is the
So
first.
we start from the beginning for
Okay. One second.
this one, no?
Okay, we are reading the question of Dr. Yassir. These 8 meters of 3 bands for agriculture monitoring. For this satellite that we have, the mission, the Minute mission has seven bands in the near infrared and visible. It has this is the bands for this mission. For next one, for the Genio 2, it will have 7 bands in the near infrared and visible, and then different bands in the sphere.
So we've been asked also for using Manoj data. So some processed images will be available soon. We perhaps recommend to follow the IEC or the ICGC on the usual LinkedIn pages to get to know how and when this data can be used. For raw images, we are not planning them to be released. They are currently used for internal research purposes. And also they will only be from Catalonia. So if that fits your research interest, please do use them. The obtention of moisture indices.
Okay, who can obtain moisture? Yes, this soil moisture data using Minute. It's using Minute and Sentinel-3. There is Sentinel-3 to obtain the thermal information, and then all fusion using SMAP, which obtains the soil moisture but at 9 kilometers resolution. Then using different algorithms, this company, what they do is obtain the soil moisture at 5-meter resolution. But it's not only with Minute, it's Minute, Sentinel-3 for thermal, and SMAP or SMOS.
And these are data usage.
If you could read the questions out loud so that people can hear, that would be great.
Perfect.
Okay, sorry, thank you. Yeah, and next question is, how about using SAR data like Sentinel-1 for soil moisture monitoring? Yeah, it can be also used. What we have done here is try to improve the resolution, and using Sentinel-2 and using this Minute this is why we have used these satellites. And there's something else.
And I think that's all.
Okay. Yeah, thank you very much for the questions.
One more question. I think that sometimes you mentioned that I think that ISARSAT is retrieving soil moisture, not only the surface, but somehow in the subsurface, you mean some penetration depth. You know how many centimeters, or can you?
Yeah, they are developing it now, which means this is an ongoing project, and they want to arrive like more than 50 centimeters. They want to arrive to to this 50 centimeters where the information of the water content is more important for the agricultors. This is the feedback that we obtain from them. That is much better to have this information than the surface soil moisture. And now they are working in this project.
That's very interesting. Yeah. And regarding, early warning and disaster management, you have some feedback from the government and the real application, risk mitigation. How is the strategy or still, I understand that these are the first steps, but I think that that's very interesting and with a real, important, application for the community.
Yeah. Well,
So
this
maybe this
is
is a question for the future.
yeah, exactly. It's for a future. I think that for disaster management, what we have now here in Europe, at least, is what I can talk maybe better, is that we have this Copernicus service emergencies and all these satellites working for these emergencies. But missions as Menut can help can help to improve the the decision making, maybe if there is not enough information due to the temporal resolutions, for instance, maybe because if these satellites give you information every week, for to manage an emergency, of course, it's necessary more satellites, and it can be used as this complementary. But I think that, well, now it's the beginning in our case. I think that it's necessary to first to do these all use cases and all these pilots to see how these missions behave, and then to learn and to see how it works. Yeah, it's a good point. Mhm.
So we also have another question. Is the presence of
Yeah.
clouds a considerable challenge for measuring the different indices? And about the reconstruction of a cloudy area. So perhaps we can skip the second part because we haven't yet explored it.
Yeah,
And for the clouds, yes, they are. In fact, there was an index that had some white spots, and it was a wild cloud passing by.
exactly. The presence of clouds is really a challenge because if you remember, there was an image in
Perhaps we
the
can find it.
yeah, maybe I don't know if we can share. It was
It was
this
this one.
one. This image here in the bottom, this area where no dots, where there is no dots here, is because of the cloud. And then if this information, if you have a lot of this cloudy completely, you cannot get this information. This is why maybe they ask it about the SAR data, because then you don't have these problems with the clouds. And this is, in this case, yeah, it's always challenging. This is why the complementarity we think for different satellites. And
Yeah,
I
maybe-
think yeah, there is another question here that oh, just 1 second, let's move. Compassion. Is which of your team associates offers the clearest API? Which of your team offers the clearest? I don't know if I understand the question.
No, me neither.
Is that, well, if it's the case, the data from Menut will be available for free in short, but it will be offered in a web page, and people can download. It won't be using an API for the moment.
Yes, thanks. Perfect. I think that's it.
Okay, so time for last question. If not, we make it. Maybe we can conclude this talk. Last call for the last question. If not, congratulations for your very nice work. And enjoy, the holidays, and Bon Nadal. See you soon.
Thanks a lot. Merry
Thank you.
Christmas. Bye.
Thank you to everybody. Bye.